On Saturday afternoon, a 5.5-ton rock from space hit the air above Cape Cod at 42,000 miles per hour and broke apart 31 miles above the water. NASA confirmed it within 48 hours, named the meteorite fall, traced the trajectory, gave the public a clean closure on what had been for 2 days the loudest unexplained sound on the East Coast. Case closed. And then, on Monday night, the sky over America did it again, and again, and again. By the time the 4-day window had closed, 5 separate fireball events had been observed across the eastern half of the continent. One of them was federally confirmed. The other 4 are still pending, and the gap between what is hitting our atmosphere and what gets formally attributed has just become impossible to ignore. If you want to know what that gap actually means, hit subscribe and stay with me. Drop a comment with where you're watching from and whether you saw anything in the sky on Monday night. Now, let's get into it. Part 1. The closure that opened a door. Saturday afternoon, May 30th, 2026. 2 minutes past 2 in the afternoon, Eastern Daylight Time, the sky above northeastern Massachusetts and southeastern New Hampshire is choked with the cloud deck of a southward tracking nor'easter that has no business being there on the calendar position it occupies. Tens of thousands of feet of moisture and turbulence and condensation sit between the people below and the open atmosphere above, and somewhere inside that ceiling, travelling at 42,000 miles per hour, a stony meteoroid 5 feet across and weighing 5.5 metric tons begins to break apart. Nobody sees it. That single fact, that the most consequential atmospheric entry over the eastern United States in years happened above a cloud deck so dense that not one ground observer along the entire Massachusetts coastline got a clean visual on it, is the entire reason the case took as long as it did to close. Because of that cloud deck, the case looked, for several hours, like a mystery. Boston police got calls about a possible explosion in Brighton. A faint, uncertain seismic catalogue entry appeared near Providence County in Rhode Island. The acoustic footprint stretched from Cape Cod to the Connecticut border and back inland to Cambridge and Concord and Arlington. People who'd never thought about meteorites in their lives heard something hit the air above them and looked up at a featureless grey ceiling and went back to whatever they were doing. For the better part of 48 hours, what made the noise was an open question, and then, on Saturday at 6:41 in the evening, NASA Space Alerts posted the first piece of the answer to its public feed. Eyewitnesses in New England, paired with a flash registered by the geostationary lightning mapper aboard NOAA's GOES 19 satellite at exactly the moment of the boom, indicated a bright fireball. The instrument had been built to watch lightning. It had caught something else. The flash sat north of Cape Cod, with no thunderstorm activity anywhere near it, and the satellite had been the only thing watching the right piece of sky from above the cloud. 22 hours later, NASA came back with the rest of the answer. The meteor was about 5 feet (1.6 meters) in diameter, with a mass of approximately 5.6 metric tons, and it had entered Earth's atmosphere at roughly 42,000 miles per hour. It had travelled through the upper atmosphere from the northwest to the southeast for about 26 miles, before breaking up at an altitude of about 31 miles. The energy released at breakup was equivalent to roughly 230 tons of TNT. That was the sonic boom. And the fragments, the residue of a 5.5 metric ton stony body that did not finish vaporizing in its passage through the air, had completed their fall into Cape Cod Bay. So now there was a meteorite at the bottom of Cape Cod Bay. Probably small fragments, probably scattered across a footprint of seabed wider than any practical recovery operation could ever address, almost certainly never to be picked up and brought into a laboratory and studied by anybody. But there, real, resting on a layer of silt and shell and old fishing gear, the physical remainder of a body that had been falling toward the sun in a heliocentric orbit for an unknown number of millions of years before it hit the air above a state with 7 million people in it on a holiday weekend. That was the resolution. The case was, in the conventional sense, closed. The video we made about that closure was published yesterday. The video from 3 days before that, on the original boom, was published while the case was still open, and the South Carolina event from May 28th was still unresolved. And most of what we said in that earlier video about how confusing the air was acting along the East Coast right then was about to be confirmed by what NASA put on the public record the next day. The trajectory of the investigation had moved from mystery to confirmation in less than 2 days, which by the standards of how federal attribution of atmospheric events normally proceeds, is remarkable. A bright fireball caught by a weather satellite during the wrong storm pattern at the right time of day got resolved faster than most cases ever do. And then, while we were still describing what NASA had said, something else started happening. The sky over America, the country we live in, the continent we are sitting on top of, began to do something that closed cases do not usually do. The case stayed closed. Cape Cod was confirmed, the meteorite had fallen, but the events did not stop. Let me tell you what has happened in the 72 hours since the Cape Cod Bay meteorite fall was confirmed. Sunday night into Monday morning, no significant fireball reports across North America. The sky was clear in a lot of places. The Omega block configuration that has been parked across this continent for almost 3 weeks had finally started to relax slightly along its eastern flank. The Memorial Day weekend was winding down, and the atmosphere was doing what an atmosphere ordinarily does on a late spring evening: quiet. Monday afternoon, into Monday evening, normal again. The Storm Prediction Center had a slight risk for severe thunderstorms in the northern plains, focused on western North Dakota and eastern Montana, where supercells were going to fire along a cold front and produce hail and damaging winds and possibly a tornado or two. Texas had some storms. Florida had thunderstorms. Most of the country was watching its own weather. Nobody outside of a small group of people who follow bolide events for a living was thinking about meteors at all. And then Monday night, around 10:40 in the evening Central Daylight Time, the sky above Wadsworth, Ohio, lit up. A driver in Wadsworth, a town in Medina County between Cleveland and Akron in the kind of geography where the suburbs run out and the open country begins, had a dashcam running. The footage shows a residential street, headlights, the routine motion of a car going home on a Monday night. And then, at the top of the frame, an object enters from above and travels across the visible sky for what eyewitnesses across the region would consistently describe as at least 8 seconds. 8 seconds. You need to understand something about 8 seconds. A typical sporadic meteor, the kind you see during a normal stargazing session on a clear summer night, lasts less than a second. A bright shooting star might last 1.5 seconds, maybe 2. The Perseids in August produce a few each hour with luminous trails in the 2 to 4 second range, and those are the bright ones, the ones worth pointing at and saying, "Did you see that?" 8 seconds is in a category most people who do not study meteoroids professionally have never personally seen. 8 seconds means you have enough time to start to react, to recognize what you're looking at, to call somebody else over to look. 8 seconds means the object entering the atmosphere is bright enough and large enough, and on a shallow enough trajectory that it is illuminating itself across hundreds of miles of sky, for what counts in this kind of event as a small eternity. That dashcam in Wadsworth caught the whole thing. Within minutes the reports started coming in, not from Wadsworth alone, from across Ohio, where the bright pulse of the fireball was visible to drivers and porch sitters and people leaving baseball games, from Michigan, where it crossed an entire state's worth of sky, from Indiana and Illinois, from Wisconsin and Pennsylvania, from Kentucky, from across the border in Ontario, where Canadian witnesses watched the same atmospheric trail. By the time the social media reports had been compiled into anything resembling a coherent footprint, the fireball had been seen in at least 7 of the United States and at least 1 Canadian province, which puts the lateral coverage of its visibility envelope on the order of 1,000 to 1,200 miles from end to end. Independently at 10:41 Central Daylight Time 1 minute later, a public webcam on EarthCam mounted on a Chicago building facing west toward Lake Michigan captured a luminous object descending into the camera's field of view. The Chicago EarthCam is one of dozens of publicly accessible streaming cameras that watch various pieces of American sky at all hours. It does not usually catch fireballs. It is not designed to catch fireballs. It is there for the people who like to look at Chicago at night. On Monday at 10:41 Central Daylight Time, it caught 1. The Chicago capture is critical because it gives us a second independent visual angle on what is almost certainly the same atmospheric entry as the Wadsworth dashcam. The exact orbital reconstruction is the kind of work that takes the American Meteor Society and academic researchers days or weeks to complete, and the public attribution is not yet available. But the combination of dashcam footage from Ohio, a separate dashcam-style submission from Chris Palka of Carey, Ohio, that the local affiliate 13ABC in Toledo has been amplifying, and the Chicago EarthCam capture, all time-stamped within a window of minutes, gives you the kind of multiply-confirmed, multiply-imaged atmospheric event that ordinarily takes weeks to assemble. We had 3 or more publicly available video angles on this thing within hours, and the federal detection chain that resolved Cape Cod in 48 hours has, as of this recording, not issued a comparable public confirmation for what crossed the Midwestern sky on Monday night. That gap is not nothing. We will come back to it. Before we close out the opening of this story, I need to tell you about one more fireball, because once you start counting on a 4-day calendar, the count gets noticeable fast. While the Midwestern fireball was being reported across the 8 political units of its visibility envelope, in central Maine, on the shore of Seebeck Lake, a public webcam called Star Live Streaming, broadcast on YouTube by the Boston and Maine Live channel, was running its normal nightly footage of the lake under whatever moonlight and cloud was available. The camera looks out at a body of water in Piscataquis County, surrounded by the kind of rural Maine landscape that does not generate a lot of light pollution. It is the kind of webcam people leave running because the view is meditative, the way some people leave a fish tank visible on their desk. On Monday evening, the Star Live streaming camera caught a green fireball. A viewer who happened to be watching the stream described the object as appearing slow, appearing huge, and appearing as if it was under the clouds. That last description is interesting, and it is interesting in a way that is worth pausing on. The phrase, under the clouds, suggests that the fireball was visually behind the lower cloud layer from the observer's perspective. That does not necessarily mean it was physically below the cloud layer. The fragmentation altitude of a fireball this bright is somewhere in the range of 20 to 40 miles, well above any normal cloud deck. What the description most likely means is that the cloud was between the observer and the fireball, which is consistent with the fireball entering the atmosphere at high altitude and being seen through a partial cloud opening. The green colour is also interesting because green is a signature colour in fireball spectroscopy. The light that comes off a fireball during atmospheric ablation is generated by the heating of the meteoroid surface materials to several thousand Kelvin, which excites specific atomic transitions that radiate at specific wavelengths. Magnesium and iron, both of which are common in stony meteorites, produce strong emission lines in the green portion of the visible spectrum at temperatures consistent with bright fireball ablation. A bright green fireball is consistent with a stony or stony iron meteoroid, undergoing the kind of vaporization that an atmospheric entry produces. The Maine event and the Midwestern event happened within roughly the same nighttime window, allowing for the 1-hour offset between Central Daylight Time and Eastern Daylight Time. The geographic separation between Seebeck Lake, Maine, and Wadsworth, Ohio, is on the order of 1,200 miles. A single fireball cannot illuminate the sky simultaneously over a region that large. These are 2 independent atmospheric entries on the same evening, within roughly the same approximate hour, separated by 1,200 miles of latitude band. 2 independent atmospheric entries within roughly the same hour. Hold that. So the count at this point in the story looks like this. May 30th, Cape Cod confirmed. June 1st, Midwest and Great Lakes, multiple camera confirmation across at least 8 states. June 1st, Maine, livestream capture. Plus, in the broader social media aggregation, additional eyewitness reports from across the 7-state band that may or may not be different entries from the Wadsworth event, and a Chicago EarthCam frame that is probably the same event captured from a different angle, but might be a closely timed second body. The conservative physical count of independent atmospheric entries within the 4-day window is 2, plus a probable third. The editorial count, the count you would use if you were trying to describe to somebody at a dinner table how strange the past 4 days have felt, is 5. 5 fireballs in 4 days over America. And the question, which is the question that the next 2 hours of this video will try to take seriously, is what that actually means. Because it is one thing to say that 5 separate atmospheric events have been observed across the continent in a window that short. It is another thing to figure out whether that count is at the high end of normal, or off the chart of normal, or something else entirely. And it is yet another thing to figure out why the federal detection chain that confirmed Cape Cod inside 48 hours has not, as of right now, produced equivalent confirmations for the others, and what that asymmetry is telling us about what we actually know about what is hitting our atmosphere. The case on Cape Cod is closed. The case on what we are looking at is just beginning. Let me show you what we know. Part 2, 8 states, 1 sky, 1 Monday night. Let us go back to 10:40 Central Daylight Time on Monday night, June 1st, and walk through the Midwestern fireball event in the kind of detail that a documentary investigation requires. Because what happened on Monday night is the kind of event that, in a normal week without a Cape Cod confirmation sitting directly behind it, would have led every science feed in the country by Tuesday morning. The fact that it has not, that the conversation about Monday night is being absorbed into the larger conversation about Cape Cod and into the larger conversation about why the sky has felt different over America for the past month, is the first piece of evidence that something about how we attribute atmospheric events has shifted under our feet without us noticing. The driver in Wadsworth, Ohio, whose dashcam caught the fireball, was on what appears from the footage to be a suburban arterial road. The frame is dominated by the standard furniture of suburban Ohio at night. Telephone wires across the top, the silhouettes of trees, the porch lights of houses set back from the road, and then, in the upper portion of the frame, a luminous object enters and crosses the sky. The object is bright enough to wash out the contrast of the dashcam's exposure for a fraction of a second, which is a strong indication that the apparent magnitude of the fireball was in the deeply negative range, brighter than the full moon, possibly approaching the brightness of a fireball classified as a bolide. The luminous trail persists across the visible portion of the sky for the 8-second duration that eyewitnesses across the region would converge on independently. You should understand how unusual 8 seconds is in fireball observation. The vast majority of atmospheric meteoroid entries are completed in well under a second. A typical sporadic meteor, the kind you see if you spend an hour looking up on a dark night anywhere on the planet, is generated by a particle smaller than a grain of rice travelling at orbital velocities, vaporizing entirely in a tiny fraction of a second. A bright meteor, the kind you actually exclaim about when you see it, is generated by a particle the size of a pea, vaporizing across a second or two. A fireball, defined by the International Astronomical Union as a meteor brighter than apparent magnitude -4, is generated by an object somewhere between a marble and a basketball, and can last several seconds. A bolide, the next tier above a fireball, defined as a fireball that produces a terminal explosion or audible sonic boom, is generated by an object somewhere between a basketball and a refrigerator, and can last anywhere from several seconds to a dozen seconds depending on entry angle. 8 seconds places the Wadsworth object in the upper portion of the fireball distribution and approaching the lower end of the bolide distribution. The brightness, the duration, and the lateral extent of the visibility envelope across 8 political units are all consistent with each other, and they all point at the same conclusion. The object that crossed the sky over the Midwest on Monday night was not a small meteoroid. It was significantly larger than the average atmospheric entry, and in terms of total kinetic energy at entry, it was very likely in the same general class as the Cape Cod object that NASA confirmed the week before. Let me be precise about what same general class means, because precision matters here. The Cape Cod object had a pre-atmospheric mass of 5.5 metric tons and an entry velocity of 42,000 miles per hour, which works out to a kinetic energy on the order of 1 × 10⁻17 joules. That is a tremendously large number written in scientific notation, and most people do not have an intuition for what a 10⁻17 joule kinetic energy actually means, so let me translate it. It means that the energy of the Cape Cod object's motion through space, the energy that gets converted into heat and light during atmospheric breakup, was equivalent to roughly 24 kilotons of TNT, of which about 230 tons released during the terminal breakup, and the rest dissipated more gradually during the descent through the upper atmosphere. The Genios catalogue, which tracks bolide events at this energy class, registered the Cape Cod event as 1.1 kilotons of total impact energy, which is the catalogue's standard normalization. That is consistent with the NASA estimate. The Midwestern object, judged by its luminous duration of 8 seconds and its visibility across at least 1,000 miles of latitude band, is very likely in the same general energy class. Without the GOES 19 GLM signature that confirmed Cape Cod, we cannot say so with the same instrumental confidence. But the visual evidence is consistent with an entry on the same general scale. What we have then is a fireball event on the night of June 1st that was caught by at least 3 independent visual sources at the moment of entry. Let me walk through them. The first is the Wadsworth, Ohio dashcam, which I have already described. This is the most widely shared piece of footage, and is the closest thing we have to a high-quality reference video on the event. The second is a video supplied to 13 ABC, the ABC affiliate in Toledo, Ohio, by Chris Palka of Carey, Ohio. Carey is in Wyandotte County, 60 miles south of Toledo, in a part of Ohio with relatively low light pollution and broad rural horizons. The video appears to have been captured on a personal device looking out into the night sky and shows the same general atmospheric trail consistent with the Wadsworth observation, but from a different position and angle. Mr. Palka's video, like the Wadsworth dashcam, is consistent with the wider pattern of eyewitness reporting across the region. The third is the Chicago EarthCam, which I have already described. The Chicago capture is time-stamped at 10:41 Central Daylight Time, 1 minute after the broader social media report of the fireball. The relationship between the Chicago capture and the Wadsworth dashcam is technically ambiguous on the strict facts. They could be the same atmospheric event observed from positions separated by approximately 350 miles, in which case the 1-minute timestamp difference is well within the uncertainty of social media report aggregation. Or they could be two closely spaced atmospheric events occurring within a minute of each other along the same general latitude band, which would be unusual but not unprecedented. For the editorial framing of this video, we treat the multiple camera angles as part of the same observational cluster, without claiming a definitive count of how many distinct atmospheric entries they represent. The point that the editorial framing emphasizes is that whatever the precise count, the Midwestern sky on Monday night produced multiple independent video records of a fireball or fireballs significantly brighter and longer than what an ordinary spring evening generates. Beyond the video, the eyewitness aggregation across social media has been extensive. The independent monitoring account compiled reports from witnesses in Ohio, Michigan, Indiana, Illinois, Wisconsin, Pennsylvania, and Kentucky, and added that observers across the border in Ontario, Canada, reported the same atmospheric trail at the same approximate time. That gives us an 8 political unit visibility envelope, which, if you sketch out the geometry of an atmospheric entry at 30 miles altitude, visible to ground observers within several hundred miles of the entry point, gives you a horizon-to-horizon footprint consistent with a single bright fireball seen from the entire Great Lakes Basin and adjacent regions. The American Meteor Society's pending Fireball Reports Queue, which is the operational venue for crowdsourced fireball event compilation in the United States, was, by Tuesday morning, in the process of aggregating regional eyewitness submissions for the event. The AMS workflow takes the geographic distribution of reports, the timing reported by each witness, the directional headings reported, and the brightness estimates, and uses them to reconstruct the trajectory of the atmospheric entry. This is a process that typically takes anywhere from a few days to a few weeks to complete, depending on the volume of submissions and the geographic spread. The fact that, by the time of this video being recorded, the AMS event had not yet been formally catalogued with a unique identifier is consistent with the normal AMS processing timeline, and is not, by itself, a sign of any unusual delay. What is unusual, however, is the contrast between the AMS processing timeline for the Midwestern event and the GOS 19 GLM processing timeline that delivered Cape Cod in 48 hours. That contrast is structural, not accidental, and it is part of what this video is going to try to explain in detail in a later segment. For now, hold the Monday night Midwestern fireball in your mind as one of the central evidentiary pillars of the cluster. 8 states, Ontario, 8-second luminous trail, multiple independent video angles, AMS aggregation in progress, and no federal-level energy attribution yet. Hold that, and let me tell you about the second event from the same evening, the one over Maine, because the Maine event is the piece of the cluster that I find personally the most evocative, and not because of anything dramatic about the meteoroid itself. It is evocative because of how it was caught. A man, whose social media post I'm reading from carefully and whose framing I will paraphrase, was watching the star live streaming feed of Sebec Lake on YouTube on Monday evening. He was watching, in other words, a webcam, the kind of slow ambient public feed that thousands of people have running in the background on a second monitor or on a tablet on the kitchen counter, while they fold laundry or finish a meal. He noticed something in the sky, and he watched it long enough to capture a screenshot from the stream that shows a luminous object descending toward the horizon line of the lake. That is how the public record of the Maine fireball was created. By accident. By a stranger watching a webcam feed of a lake in central Maine, paying enough attention to recognize that something unusual was happening in the sky above the water, and having the presence of mind to capture the image. The webcam itself was not designed to catch fireballs. The Starlive streaming camera at Sebec Lake is operated by a YouTube channel called Boston and Maine Live, which runs a network of webcam feeds focused on scenic views of various Maine locations. The cameras are there because some people like watching weather happen in slow motion on a lake. They were never intended as part of any kind of atmospheric monitoring infrastructure. And yet, on Monday evening, one of them happened to be looking in the right direction at the right second, and it recorded a piece of footage that, in the absence of any federal sensor at the same location, is now the entire public record of an atmospheric entry that probably deposited some kind of meteoritic residue somewhere in the forests of central Maine. I want you to sit with that for a moment, because it is the kind of detail that sounds incidental, but actually carries the central thread of this whole video. The federal detection chain caught Cape Cod because GOES 19 happened to be the right instrument, in the right orbit looking at the right piece of sky in daylight. The main fireball, on Monday night, was caught by a webcam aimed at a lake. The difference between those two detection layers, the difference in sophistication, the difference in reliability, the difference in what each is designed to do, is the difference between a closed case and an open observation. The Cape Cod case is in the federal catalogue because a 500 frame per second instrument with hemispheric coverage saw it. The main fireball is in the public record because a stranger was watching a webcam. If the stranger had not been watching the webcam, the main fireball would have left no public record at all. That is what I want you to take with you into the next part of this video. Not the fireballs themselves, but the asymmetry of how we know about them. We know about Cape Cod with 5-digit precision because the right satellite was looking. We know about Maine because someone happened to be looking at a webcam. And we know about the Midwest because dashcams have become standard equipment on American cars and the Chicago skyline happens to be on a public livestream. The atmospheric events are real. The federal record of them is not. Part 3. The cluster takes shape. 5 fireballs in 4 days. Let me say it again, because the calendar density of this thing is the part that makes you stop and look. Saturday afternoon, Cape Cod, daylight bolide above a nor'easter cloud deck, confirmed by NASA, meteorite fall confirmed into Cape Cod Bay. Sunday, nothing. Monday afternoon, normal severe weather pattern across the northern plains, nothing unusual on the meteoroid side. Monday night, 10:40 Central, the Midwest fireball lights up at least 8 political units of sky and is captured on Ohio dashcam. Chris Palka's video out of Cary, Ohio that 13 ABC in Toledo is now broadcasting, and the Chicago EarthCam facing west toward Lake Michigan. Monday evening, separately, central Maine, green fireball captured on Sebec Lake livestream during what was clearly an entirely independent atmospheric entry. That is the bare arithmetic of the cluster as we have observed it. Now I want to step away from the individual events for a moment and walk you through how unusual the bare arithmetic actually is. Because the answer to that question, whether 5 events in 4 days is at the high end of normal, or off the chart of normal, or something else entirely, is going to determine the entire frame for the rest of this conversation. If it is normal, we have an interesting week and not much else. If it is off the chart, we have to start asking different questions. And the answer, like a lot of answers in atmospheric science, turns out to be more nuanced than either of those two framings would predict on their own. The relevant federal catalogue, the one that defines the baseline against which all this is measured, is the Center for Near-Earth Object Studies Fireball and Bolide Reports Catalogue, maintained by the Jet Propulsion Laboratory and accessible publicly online. CNEOS catalogues bolide events at the threshold detection level for US government sensors that contribute to the catalogue. That threshold corresponds to events with total impact energies above approximately 73 gigajoules, which translates to events brighter than a certain magnitude limit and energetic enough to produce a detectable signal in one of the contributing sensor networks. Historically, the CNEOS catalogue records approximately 80 to 100 bolide events globally per year at and above that detection threshold. That is the baseline, about 100 events per year, planet-wide. The catalogue records a smaller subset of these at the kiloton class energy level, which is the class that the Cape Cod object falls into. Historically, the kiloton class subset runs at about 15 to 25 events per year globally. That is the comparison reference. A small fraction of those occur over the contiguous United States, in proportion to the United States' share of the global land area. the expected rate for kiloton-class events over the lower 48 states is in the range of 2 to 5 events per year. Now compare that baseline to the past 3 weeks of Keneos catalogue entries. The 4 most recent events in the catalogue before today are May 7th, 2026, at 32.5 degrees north and 36.8 degrees west in the mid-Atlantic Ocean at 0.2 kilotons, May 10th at 45.5 degrees south and 109.8 degrees west in the South Pacific at 0.19 kilotons, May 21st at 46.6 degrees north and 133.1 degrees east in eastern Russia at 0.12 kilotons, and then May 30th, Cape Cod at 42 degrees north and 70.5 degrees west at 1.1 kilotons. The Cape Cod entry is between 5 and 9 times the size of any of the prior 3 weeks' events. That in itself is not anomalous. The Keneos catalogue has a wide energy distribution, and a kiloton-class event is on the larger side but not exceptional. Over the past decade, the catalogue has contained multiple events well above 1 kiloton, including the November 2020 Bering Sea event at 173 kilotons, the Chelyabinsk event of February 2013 at approximately 440 kilotons, and the Bering Sea 2018 event at approximately 173 kilotons. The Cape Cod event is at the low end of the kiloton class, not the high end. What is unusual is the calendar density. A single kiloton class event over the lower 48 states is, in any given year, a roughly 2 to 5 event annual rate. If we add the Midwestern Monday night event to the count, even tentatively, on the basis of the visual evidence rather than instrumental attribution, we have 2 kiloton-class candidate events over the lower 48 states inside a 4-day window. That is a rate compression of the entire annual baseline into a single short interval. The technical question is whether that compression is consistent with random Poisson statistics, or whether it is outside the tail of what randomness would predict. The answer turns out to be that it is at the tail, but not outside it. If you take a baseline US annual rate of 3 kiloton-class events and ask what the probability is of seeing 2 of them inside any 4-day window in a given year, the answer is somewhere in the range of 3 to 7%. That is uncommon, but not extraordinary. A cluster of this density, in expectation, will happen somewhere in the US catalogue about once every 25 to 40 years under the null hypothesis of pure random Poisson statistics. We are not, in the strict statistical sense, looking at something that should be impossible. We are looking at something that is at the high end of normal variation, and that happens to have arrived in a window where the public is already paying close attention because of Cape Cod and the New England sonic boom investigation from earlier in the week. That is the precise statistical posture you should hold the cluster in. It is real. It is at the tail of expected variation. It is the kind of thing that does happen, that has happened before, that will happen again, and that has just happened to compress itself into a particularly visible window of the American calendar. Now there is a second framing that the data also supports, and this is the framing that I find most interesting, and the framing that the editorial spine of this video is going to lean on for the rest of the discussion. It is the framing that the cluster is at the tail of expected variation, but the public perception of it is being amplified by the fact that the federal detection chain is structurally unable to keep up with what is happening in real time. What I mean by that is the following. The Keneos catalogue runs on a multi-day to multi-week update cycle. When a bolide event occurs and a contributing sensor catches it, the data flow into the catalogue through a processing pipeline that involves multiple federal agencies and that operates on a timeline measured in days at the fastest and weeks at the more typical pace. The Cape Cod event was an exception to the standard timeline because NASA Marshall ran the energy and trajectory analysis on an accelerated schedule and pushed the result out to public communications within 48 hours. That is unusually fast. The typical Keneos update for an event of comparable energy class would arrive somewhere between 2 and 4 weeks after the event. So the question of whether the Midwestern Monday night event will appear in the Keneos catalogue at all, and at what energy class, is genuinely unanswerable at the moment. We will know in days or weeks. The American Meteor Society's reconstruction work will produce an event identifier and a trajectory estimate inside that window, and the Keneos update will probably follow. As of this video's recording, none of that has happened. What that means for the framing of the cluster is that the public record we have access to right now is incomplete. We have multiple independent video records of an event that is consistent with a kiloton-class atmospheric entry, but we do not have the instrumental confirmation that would let us say so with the same confidence as we can say about Cape Cod. We will get the confirmation probably. We will get the energy estimate probably. We will get the trajectory probably. But we do not have them now, and right now, in the middle of the cluster, is when the public is looking. The geographic distribution of the cluster is also worth pausing on, because it tells you something about how the events were observed, even if it does not tell you very much about why they happened. All 4 anchor events are concentrated along the same general latitude band, roughly 40 to 43 degrees north, across the eastern half of North America. Cape Cod is at 42 north. Wadsworth, Ohio, is at 41 north. Sebec Lake, Maine, is at 45 north. The 7-state band that the social media aggregation covers extends from about 37 north in southern Kentucky to about 45 north in northern Wisconsin and the Upper Peninsula. The naive interpretation of this latitude concentration is that something is hitting the same band of atmosphere from above, that the meteoroid stream, or the parent body or whatever is responsible for the cluster, is geometrically aimed at that band. The more sober interpretation is that the latitude band that includes the population centres of the Great Lakes states, New England, the Mid-Atlantic and southern Ontario, is also the band that has the densest population of human observers, the densest network of consumer dashcams, the densest network of public webcams, and the densest network of social media reporting infrastructure in North America. If atmospheric events were occurring at the underlying CNEOS baseline rate uniformly distributed across the continent, you would expect the observed events to concentrate where the observers concentrate. The geographic distribution is consistent with that null hypothesis without requiring any preferential targeting of the latitude band. It does not rule out a stream encounter or a fragmented parent body, but it does not require one either. We will come back to the stream encounter question in a later part of the video, because it is the kind of speculative framing that the channel takes seriously and walks through carefully. For now, the cluster is established, Cape Cod confirmed, Midwest probable, federal confirmation pending, Maine probable, federal confirmation pending, geographic distribution consistent with observer density, statistical density at the tail of expected variation but inside it, federal detection chain showing significant asymmetry between what it caught and what it has not yet caught. That is the shape of what we are looking at. Now let me show you why the federal detection chain works the way it does, and what that asymmetry is actually telling us about the gap between what enters the atmosphere over America and what gets formally attributed. Part 4. The instrument that caught Cape Cod. The geostationary lightning mapper mounted aboard the GOES-19 satellite at 35,786 kilometers above the equator is the single most important piece of context for understanding why the Cape Cod case closed in 48 hours and why the Midwest and Maine cases have not yet. The instrument, the orbit, the mission profile, and the data pipeline that feeds the public release of GLM data are worth walking through carefully, because once you understand what GLM is and what it is not, the asymmetry of the cluster's federal attribution stops looking mysterious and starts looking structural. The GLM was designed primarily to detect lightning. That is the headline mission. Lightning detection from geostationary orbit had been, until the GOES-R series of satellites came online in the late 2010s, a capability the United States did not really have. Ground-based lightning detection networks, including the National Lightning Detection Network operated commercially by Vaisala, had given the country a robust ability to map cloud-to-ground strikes in real time, but the full picture of lightning, including the intra-cloud and cloud-to-cloud activity that constitutes a substantial fraction of total lightning, had been harder to acquire. The GLM was built to fix that. It is, fundamentally, a high frame rate optical camera tuned to look for the specific transient flashes of light that lightning produces. The technical specifications are worth knowing. GLM operates at 500 frames per second, which is 20 times the frame rate of standard television video. It has a resolution of approximately 8 kilometers at the equatorial sub-satellite point, and somewhat less at higher latitudes due to the geometry of viewing the curved Earth from a fixed position above the equator. Its field of view covers the entire Western Hemisphere visible from the satellite's longitude, and it is calibrated to detect transient luminous events in a specific spectral band centered on the 7 to 7.4 nanometer oxygen emission line. which is the spectral signature of lightning channels and a few other natural high-temperature phenomena. One of those other phenomena is a bolide. A bolide entering the atmosphere produces an intense, brief, luminous flash at the moment of terminal fragmentation. The flash is in the same spectral range that the GLM is tuned to detect. The intensity is well above the detection threshold for any reasonably bright fireball, and the duration is consistent with the time resolution of the GLM's frame rate. From the perspective of the instrument, a bolide looks like a particularly bright, particularly compact, particularly off-pattern lightning flash, with no associated thunderstorm activity to provide context. GLM is not designed to attribute bolides, it is designed to attribute lightning. But the same physics that lets it see lightning also lets it see bolides, and over the past several years a small community of researchers at the Cooperative Institute for Meteorological Satellite Studies at the University of Wisconsin-Madison and at other institutions has developed an operational workflow for identifying and characterizing bolide events in GLM data. The most famous public demonstration of that capability before Cape Cod was the Lake Erie bolide of March 2026, which we covered on this channel during the original Mystery Boom investigation. The Lake Erie event was confirmed by GLM data with a level of timing and trajectory precision that ground-based eyewitness aggregation alone could never have provided. It became, in the small community of bolide researchers, the gold standard demonstration of GLM as a bolide attribution instrument. When the Cape Cod event happened on Saturday, May 30th, the operational workflow that had been developed for Lake Erie was sitting ready. The GLM caught the flash. The cooperating researchers at NASA Marshall ran the analysis, and by Saturday evening, the public release of the event characterization was complete enough for NASA Space Alerts to post the first communication. That is why Cape Cod resolved in 48 hours. It is also why the Midwest and Maine events have not yet resolved in the same timeline. GLM is in geostationary orbit above the equator. Its line of sight to a bolide event depends on whether the event occurred in clear enough sky from the satellite's point of view to register a detectable optical flash. During the day, the GLM detection threshold is calibrated for daylight backgrounds. At night, the threshold is different. The detection of nighttime atmospheric flashes against dark backgrounds operates on different signal-to-noise considerations than daylight detection. The instrument does see nighttime bolides. The Lake Erie event was a daylight event. The Cape Cod event was a daylight event under cloud cover. The fact that GLM caught Cape Cod despite the cloud deck is itself a notable demonstration of the instrument's sensitivity, because the cloud-top reflectance of a bolide flash from below the deck is a complex optical signature that requires careful interpretation. The Monday night Midwest fireball occurred at 10:40 Central Daylight Time, which is approximately 3:30 Coordinated Universal Time on June 2nd. That is the middle of the night across the relevant longitude band. The GLM was looking at North America. If the event was bright enough to register in the instrument's nighttime detection threshold, the flash data is in the GLM archive. The processing pipeline that would extract it and attribute it has not yet, as of this recording, produced a public output. That could mean the data is being processed, and a public attribution is forthcoming on a normal post-event timeline. It could mean the flash was below the nighttime detection threshold, in which case the event will be attributed through the American Meteor Society eyewitness aggregation pipeline and the CNEOS catalog update on the standard multi-week timeline. Either is consistent with the operational reality of the detection chain. The main fireball, similarly, occurred at night. The same considerations apply. The Star live streaming webcam capture provides a public visual record of the event, but a webcam is not a calibrated scientific instrument. The energy estimate, the trajectory reconstruction, and the formal CNEOS attribution will, if they come at all, come through the AMS pipeline on the standard timeline. So the asymmetry of the cluster's federal attribution, the gap between the 48-hour Cape Cod resolution and the indefinite pending status of the Midwest and Maine events, is not evidence of any kind of concealment or selective disclosure. It is evidence of the structural reality that the federal detection chain works best in daylight, with GLM as the primary instrument, and operates on a much slower timeline at night, when AMS eyewitness aggregation is the primary attribution pathway. I want to push on the Lake Erie precedent for a moment, because the comparison between Lake Erie and Cape Cod, and the comparison between both of those and the Monday night cluster, is what gives the GLM attribution chain its shape. Lake Erie happened in March 2026, over a populated region with relatively clear skies, in daylight, with multiple ground-based observers contributing visual confirmation almost immediately. The GLM signal was clean, the energy estimate came together quickly, and the cooperating researchers at the University of Wisconsin-Madison were able to demonstrate, on a publicly accessible timeline, that the GLM data could deliver a level of timing and trajectory precision that the eyewitness aggregation pipeline could not match on its own. Lake Erie became, in the small world of bolide researchers, a kind of proof of concept that the existing GOES satellite infrastructure had, almost as a side effect of its lightning detection mission, given the country a working real-time bolide attribution capability that nobody had explicitly designed it for. Cape Cod was the second public demonstration of that capability in conditions that were harder than Lake Erie because of the cloud deck. Cape Cod showed that even when the visual chain to ground observers is broken by weather, GLM can still produce an attribution under daylight conditions because the cloud tops themselves illuminate from below when a bolide flash occurs within or just above the cloud layer. That signature is detectable from geostationary orbit. The Lake Erie precedent let the researchers know what they were looking at. The Cape Cod case extended the operational regime into something harder. The Midwest fireball occurring at night sits in a different operational regime. The nighttime detection threshold for GLM is calibrated against a darker background, and the signal-to-noise characteristics of a nighttime bolide flash against the dark earth are different from a daytime flash against an illuminated surface. The instrument is capable of nighttime detection. The capability has been demonstrated in academic publications going back several years, but the attribution timeline at night runs through a different processing pipeline, because the daylight workflow that handled Cape Cod was specifically tuned for the cloud top illumination signature that the morning sun provided. At night, the attribution chain has to fall back on different signal processing, and the researchers who do that work are operating on the academic publication timeline rather than the public communications timeline that NASA Marshall used for Cape Cod. That is why we have not yet heard back from the federal record on Monday night. The pipeline that would catch it is the slower one, the one that has not been augmented for rapid public release in the way the daylight pipeline was. It will produce an attribution if there is one to produce, but the timeline is academic, not public communications. This is the kind of detail that, if you are not paying close attention to how federal scientific infrastructure actually operates, looks like silence or concealment. It is neither. It is the operational reality of a detection chain that has been improving rapidly in one specific corner and has not yet improved in the adjacent corner. The improvement will come. Federal scientific infrastructure tends to evolve in response to changing observational capabilities, and the Cape Cod demonstration will probably accelerate the case for investment in nighttime attribution capability as well. But we are inside the gap between the two capability windows right now, and the gap is what the cluster has made visible. There are other detection layers that contribute to the bolide catalogue, and they are worth mentioning because the question of why the Midwest and Maine events have not produced federal confirmation in real time is, in part, a question about whether any of those other layers caught the events. Let me walk through them. The first additional layer is the US government's network of classified satellite sensors that were originally built for nuclear test monitoring. These sensors, which have been declassified in their general existence and capability, if not in their specific design, are the source of much of the historical CNEOS data on small bolides. They are part of the contributing data flow into the CNEOS catalogue, and they operate on a timeline that is, from the public point of view, opaque. When a bolide is energetic enough to register in this layer, the data eventually flows through to the public catalogue, but the timeline of the flow is not predictable from outside the agencies involved. The second additional layer is the international monitoring system operated by the Comprehensive Nuclear Test Ban Treaty Organization, which includes a network of infrasound stations distributed globally to detect the low-frequency atmospheric signatures of explosions, including nuclear detonations. The same infrasound signature that a nuclear explosion produces is also produced by a bolide of sufficient energy class. CTBTO infrasound data is a recognized scientific resource for bolide attribution and contributes to academic publications on atmospheric impact events. Whether the Monday night Midwestern event or the Maine event produced an infrasound signature detectable by the IMS network is, again, not publicly known in real time. It will be in the public scientific record eventually if it was. It is not yet. The third additional layer is the seismic network of the US Geological Survey, which can occasionally detect the ground-coupled acoustic signature of a sufficiently energetic atmospheric event. The Cape Cod event did produce a faint, uncertain seismic catalogue entry near Providence County in Rhode Island, which we covered in the earlier Mystery Boom video as the structural marker of the acoustic ground coupling from the bolide breakup. Whether the Midwestern or Maine events produced comparable seismic signatures, the answer is again not publicly known in real time. The USGS catalogue will reflect them if they did. So far it does not. And the fourth additional layer is the American Meteor Society's crowdsourced Fireball report system, which is the operational venue for citizen scientist contributions to bolide attribution. AMS receives reports through a structured online form that captures the witness's location, the time of observation, the direction of motion, the brightness, and any associated effects like sound or persistent train. The AMS workflow aggregates these reports, identifies clusters that probably correspond to single atmospheric events, and produces event identifiers and trajectory reconstructions on a multi-day to multi-week timeline depending on the volume of submissions. The AMS pipeline is, in the strict sense, where the Midwest and Maine events are sitting right now. They are in the queue. They will be assigned event identifiers. They will produce trajectory reconstructions. They will, if energetic enough to register in any of the other detection layers, eventually appear in the CNEOS catalogue. We are, in the most precise sense, in the gap between the event itself and the formal attribution. That gap is normal. It is not, in any sense, evidence of anything other than the standard operational timeline of how citizen science-driven attribution works. Now I want to step back from the technical details of the detection chain and tell you what the asymmetry between Cape Cod and the rest of the cluster is actually revealing, because it is revealing something. The Cape Cod event happened in daylight, above a dense cloud deck with no useful ground-based visual confirmation. Under any prior generation of federal detection infrastructure, the case would have stayed open for weeks or months. The acoustic footprint would have been documented through eyewitness reports. The USGS sonic boom catalogue entry would have been filed. The investigation would have proceeded slowly. Conventional explanations would have been ruled out one by one, and the bolide attribution would eventually have emerged as the best fit. The case would, in other words, have looked a lot like the May 28th South Carolina sonic boom case, which we covered in the original Mystery Boom video and which, as far as the federal record is concerned, is still open. The fact that Cape Cod closed in 48 hours instead of 48 days is a function of one specific piece of infrastructure being in the right place at the right time. GLM on GOES 19, calibrated for lightning, also happened to be the instrument that could resolve a daytime bolide above a cloud deck on minutes to hours timescale. That is a capability that the federal detection chain did not have a decade ago. It is a capability the public is largely unaware of, and it is a capability that, as the Monday night Midwest and Maine events have demonstrated, does not generalize to nighttime atmospheric events in the same 48-hour window. So the gap between Cape Cod and the rest of the cluster is, in one sense, a gap between the brand new federal capability of satellite-based daytime bolide attribution and the older citizen science-driven nighttime attribution pipeline that operates on the older timeline. We are in a transitional moment in how the federal detection chain handles atmospheric events. Some events get the new pipeline, some events get the old pipeline, and the public conversation about a cluster like this one tends to get framed as if every event should be on the new pipeline, when in fact most of them are still on the old one. That asymmetry is, in my view, the most important single fact to understand about the cluster. The federal record we have access to right now is a partial record. The events we are seeing on dashcams and webcams are real. The events the federal record reflects in real time are a subset of the events that are actually occurring. The gap between the two is the gap that this video is trying to make visible. Part 5. The air above America is in an unusual configuration. There is one more piece of context that the cluster sits inside, and it is the context that we covered yesterday in the Cape Cod confirmation video, and that we have been covering on and off for the past 3 weeks, across multiple videos on the Omega Block configuration that has been parked across the lower 48 states since the middle of May. The atmospheric pattern matters here because it provided the cloud deck that concealed the Cape Cod bolide visually on Saturday, and because it is the same configuration that may be providing the conditions under which the cluster's observational footprint, the way we are seeing it and hearing it across so many states at once, is being amplified beyond what an ordinary spring evening would produce. Let me describe the pattern, because if you have not watched the recent videos on it, the context will not be obvious. Since approximately May 17th, the upper-level atmospheric circulation over North America has been dominated by an unusually persistent configuration called an omega block. The name comes from the shape that the 500 millibar pressure surface, which is the canonical level meteorologists use to describe upper-level atmospheric flow, traces out on a map of the continent. There are two high-pressure ridges on the flanks of the continent, one in the west and one in the east, and a low-pressure trough in the middle. When you draw the contours of the high and low-pressure features together, the result looks like the Greek letter omega, hence the name. Omega blocks are not unusual in themselves. The atmosphere produces blocking patterns several times a year across various regions of the Northern Hemisphere. What is unusual about the current omega block is its persistence. 3 weeks is a long time for a single blocking configuration to stay in place. Most blocks break down within 7 to 10 days as the underlying Rossby wave structure of the upper atmospheric flow evolves. The current block has shown an unusual tendency to reconstitute itself after partial breakdowns, holding the same general shape across multiple weather systems and producing the same general regional impacts week after week. We have been covering the consequences of this persistence across multiple recent videos: the cure and threat same air mass framing from the drought break video, the continental flood forecast from the Omega block locking video, the Memorial Day weekend coastal cyclone from the bomb adjacent video, the Cape Cod bolide concealment from yesterday's confirmation video. All of these are different regional expressions of the same parent configuration. And the eastern flank of the block, which is the part that produced the May 30th nor'easter that concealed the Cape Cod fireball, has now relaxed and reorganized into the heat dome that is going to produce 90 to 95 degree temperatures across the mid-Atlantic and the northeast through Friday and Saturday of this week. The Omega block, in other words, is still in place. It has just shifted its eastern face. Here is where the cluster connects to the pattern. The Omega block creates an unusually stratified upper troposphere across the regions inside its footprint. The Boston area forecast discussion at around the time of the Cape Cod event documented 8 to 10 degrees Celsius per kilometre. Lapse rates between 1,000 and 950 millibars, which is an unusually steep vertical temperature gradient at the low altitudes where atmospheric acoustic propagation is governed. The Boston discussion also documented an anomalously low altitude for the 925 to 850 millibar low-level jet, which is the band of stronger winds that typically sits a few thousand feet above the surface. The combination of steep low-altitude lapse rates and a depressed jet altitude creates conditions in which acoustic energy from a supersonic atmospheric event can propagate further laterally than it would under ordinary atmospheric conditions, because the acoustic waves get refracted and ducted by the temperature and wind gradients in ways that focus their propagation rather than letting them dissipate isotropically. That mechanism, the acoustic ducting hypothesis, was the speculative explanation we offered in the original New England Mystery Boom video for why the Cape Cod sonic boom was heard across Massachusetts, Rhode Island, and Connecticut. The 3-state acoustic footprint was unusual for a bolide of the Cape Cod energy class, and the Omega block stratification provided a plausible mechanism for the unusual lateral extent. The same mechanism, extended into the visual domain, may be part of the explanation for why the Monday night Midwest fireball was visible across at least 8 political units, and the Maine fireball was visible from a webcam in central Maine. The visibility envelope of a bolide at 30 miles altitude under standard atmospheric conditions is, geometrically, in the range of 400 to 500 miles from the entry point. An 8-state visibility envelope is consistent with that geometry without requiring unusual atmospheric conditions. The Maine fireball appearing under the clouds is consistent with a standard low-altitude observation under a high cloud deck. Neither event requires unusual atmospheric conditions to be visible at the scale that has been reported, but the editorial spine of this video does not require us to claim that the atmospheric pattern is amplifying the visual envelope of the cluster. It only requires us to acknowledge that the same atmospheric pattern that concealed Cape Cod from ground observers visually is the same configuration that has been shaping every weather story across this country for the past 3 weeks, and is the same configuration that is producing the heat dome over the northeast through Friday and Saturday, and is the same configuration that will, when it eventually breaks down, transition the atmosphere over America into a fundamentally different posture than it has been in for most of the late spring. The cluster, the heat dome, the Cape Cod concealment, the nor'easter, the May 30th case, the May 28th South Carolina case, which is still catalogued as a sonic boom event with no resolution, all of these are happening inside the same large-scale atmospheric configuration, and the configuration itself is one of the most persistent omega blocks the recent climatological record has produced. That is the atmospheric context. It is in itself the kind of pattern that has been documented in the scientific literature as an expression of the broader trend of amplified Rossby wave behavior under conditions of Arctic amplification, the 4 times faster warming of the high latitudes relative to the global mean. The Rantanen paper from 2022 in Communications, Earth and Environment, the Hahn paper from 2021 in Water Resources Research, the Kornhuber paper from 2020 in Nature Climate Change, all of these provide the published scientific framework for why blocks like this one are happening more often, lasting longer, and producing more concentrated regional extremes than they did in the climate of 3 decades ago. We are inside a large-scale weather pattern that is doing exactly what the published scientific framework predicts that warming-era atmospheric flow should do. That is the background. The cluster of fireballs is happening on top of it, not because of it, but the editorial frame matters. If you have been watching this channel for the past 3 weeks, you have watched the atmosphere over America compress its expression of nearly every kind of weather event into the same general pattern. Drought breaks, floods set up, heat domes build, cold pools dive south, nor'easters spin up out of season. And now, bolide events appear at the calendar density of the high end of normal variation, and the federal detection chain confirms one of them and lets the rest sit in the queue. Whether the atmospheric pattern is causally amplifying the cluster or simply coinciding with it, the coincidence itself is one of the most editorially striking features of the 4-day window. Now, I want to do something we do not do very often on this channel, which is dispatch a backdrop element that I do not want this video to spend any more time on than it absolutely has to. There is one other geophysical story sitting on the same calendar window as the fireball cluster, and it has been showing up in the social media reaction to the cluster, so I am going to address it briefly and then move on. On Monday night Universal Time, which translates to Monday evening Eastern Time, a magnitude 6.2 earthquake struck the Tyrrhenian Sea region of southern Italy, at a focal depth of approximately 243 kilometers. That is a deep focus earthquake, in the sense that the rupture occurred well below the brittle crust of the Earth and in the descending slab of the Ionian subduction zone. The event was assessed by the United States Geological Survey at green pager alert level, which means no expected damage at the surface. It was, in terms of operational impact, a non-event for the people of Italy, although it was an interesting scientific event for the seismologists who study deep focus subduction earthquakes in the Mediterranean. I am mentioning it because some of the social media reaction to the fireball cluster has tried to connect the Italy earthquake to the fireballs. There is no mechanism by which a deep focus subduction zone earthquake in the Mediterranean is connected to atmospheric meteoroid entries over North America. The energy budgets involved, the physical pathways, the geometry, none of it works. The Italy earthquake is real. The fireballs are real. They are happening in the same calendar window, because the calendar window is what it is. They are not connected to each other. I'm dispatching this one in a single paragraph and moving on, because that is the appropriate weight to give it. Similarly, on the morning of June 2nd, 2 M1.2 class solar flares were observed from active regions near the center of the visible solar disk, including from a region that has shown an unusual anti-hail polarity configuration as it has emerged. The solar disk has been somewhat active this week. There was an R1 radio blackout in the morning hours. None of this is energetically relevant to atmospheric meteoroid entries over Earth. The kinetic energy of the Cape Cod bolide, at approximately 1 × 10 to the 17th joules, is many orders of magnitude smaller than the energy of even a small solar flare, and many orders of magnitude larger than any mechanism a solar flare could supply to a free-flying object in interplanetary space. The space weather state on Monday and Tuesday is unrelated to the fireball cluster. And finally, there have been 2 notable American aerospace stories on the calendar of the past week: the explosion of Blue Origin's New Glenn rocket during a static fire test at Cape Canaveral on May 29th, and the FAA's requirement that SpaceX conduct a mishap investigation into the May 22nd flight of Starship before launches resume. Both stories are real, and both are worth their own coverage on a different day. Neither is connected to the meteoroid cluster. Those three backdrop elements I want clear of, so that the next part of the video can focus on the cluster itself and the statistical and interpretive questions it raises. Part 6. 5 to 9 times. The baseline and what it means. Let us return to the CNEOS catalogue comparison, because the numerical comparison between the Cape Cod event and the catalogue's recent record is where the editorial framing of this video earns its weight, and where the central thesis of the cluster, that the gap between what enters our atmosphere and what gets formally attributed is wider than the audience has been told, finds its quantitative grounding. The 4 CNEOS catalogue entries before today in chronological order are May 7th, May 10th, May 21st, and May 30th. The first 3 are all in the same general size class, between 0.12 and 0.2 kilotons of total impact energy. Those are events at or near the lower threshold of the catalogue. They produced enough signal to register in at least one of the contributing sensor networks, but they were not particularly bright by the standards of catalogue events historically, and most of them happened over ocean or sparsely populated land where ground-based reporting would have been minimal. The May 30th Cape Cod event came in at 1.1 kilotons, that is 5 to 9 times the energy of any of the 3 preceding events. Now, on its own, that ratio is not the kind of departure from baseline that would itself be alarming. The CNEOS catalogue has a wide energy distribution, and individual events at 1 kiloton happen routinely. Over the past decade, the catalogue has contained several kiloton-class events per year globally, and a 1 kiloton event over the contiguous United States is well within the expected distribution of what the catalogue records. What makes the comparison meaningful is the timing. Cape Cod arrived during a 3-week stretch in which the global catalogue had been running at the lower end of its energy distribution. The 3 preceding events were all in the small bolide class, the kind of event that happens dozens of times a year globally and rarely produces any public attention. The Cape Cod event broke that pattern and arrived at 5 to 9 times the size of the recent activity. And then, on the night of June 1st, an event consistent with comparable energy class was observed across the Midwest, with multiple independent video records but without the federal instrumental confirmation that Cape Cod received. If we treat the Monday night Midwest event as tentatively in the same energy class as Cape Cod, based on the visual evidence, then the 4-day window contains 2 kiloton class candidate events over the lower 48 states. The expected annual rate for kiloton class events over the contiguous US is 2 to 5. We have compressed the entire annual baseline into a window of less than 100 hours. That is the central numerical claim of this video, and the question is whether that compression is consistent with random Poisson statistics, or whether it is outside the tail of what randomness would predict. The mathematics of random Poisson statistics give a precise answer. Take a baseline annual rate of 3 kiloton class US events. The probability of seeing 2 of them inside any 4-day window during a given year is in the range of 3 to 7%. That probability is uncommon, but not extraordinary. A cluster of this density would be expected to happen somewhere in the United States record about once every 25 to 40 years, under the null hypothesis of pure random Poisson statistics. That is the answer. We are at the tail of expected variation. We are not outside it. We are looking at something that does happen, that has happened before, that will happen again, and that has compressed itself into the public attention window of the early summer of 2026. But I want to push on this number for a moment, because the answer that we are at the tail of expected variation is the correct technical answer, and it is also, in my view, the incomplete answer. There are 2 reasons why it might be the incomplete answer, and both of them are worth walking through carefully. The first reason is that the CNEOS baseline rate of 2 to 5 kiloton class events per year over the contiguous United States is itself derived from a federal detection chain that has historically caught only a subset of the events that actually occurred. The catalogue rate is not a measurement of what is happening in the atmosphere. It is a measurement of what has been catalogued. The 2 numbers are not the same. Consider the case of nighttime atmospheric entries over relatively unpopulated regions of the lower 48 states, the kind of event that, before the era of widespread consumer dashcams and public webcams, would have produced few or no eyewitness reports and might or might not have registered in the contributing sensor networks. The CNEOS catalogue reflects a fraction of such events historically. The fraction is unknown. The actual rate of kiloton-class atmospheric entries over the contiguous United States is probably higher than the catalogued rate, by some unknown multiplicative factor. That matters for the cluster interpretation, because if the true atmospheric entry rate is meaningfully higher than the historical catalogued rate, then the probability of a 4-day cluster of 2 events is higher than the 3 to 7% figure I quoted a few moments ago. The cluster might be at the 70th or 80th percentile of natural variation instead of the 93rd to 97th percentile. We do not know. The historical baseline is the only one we have. The second reason is that the era we are now in, the era of universal consumer dashcams and ubiquitous public webcams and instant social media aggregation, has changed the observational pipeline so dramatically that what counts as a publicly observable atmospheric event in 2026 is fundamentally different from what counted as one in 1995. The fireballs that we are seeing in the public record right now are not, in any sense, the only fireballs that are entering the atmosphere over America. They are the fireballs that happen to be visible to the new observational layer of consumer-grade optical sensors that have proliferated across the country in the past 15 years. That observational shift is part of the reason the cluster looks so dense from a public perception standpoint. Atmospheric events that 20 years ago would have produced 1 or 2 eyewitness reports now produce hundreds of digital images and videos within minutes. The CNEOS catalogue rate is gated by contributing sensor networks, not by public observation. The publicly perceived cluster intensity is gated by public observation. And those two rates are diverging from each other in real time, as the observational infrastructure of the country has matured beyond what the federal catalogue was originally designed to handle. So the cluster, in the most precise framing, is at the tail of expected variation under the historical federal catalogue baseline. But the public perception of the cluster is being amplified by the fact that observational saturation has reached a level where events that would historically have gone uncatalogued are now appearing in public videos within minutes of occurring. The federal record we have access to is structurally behind the public observational record. The gap is not a gap in attribution. It is a gap between 2 different historical eras of how atmospheric events get observed. I want to be careful here about what I am claiming and what I am not claiming. I am not claiming that the fireball cluster is evidence of an increase in the underlying meteoroid flux at Earth. I have seen no evidence to support that claim, and the published scientific record on the long-term variability of the meteoroid environment at Earth does not suggest such a shift on the timescale of weeks or months. The flux of small bodies into the atmosphere has been measured in various ways, and does not show short-term variability of the kind that would produce a 4-day cluster. I am claiming that the cluster is at the tail of expected variation under the historical federal catalogue baseline, that the public perception of the cluster is being amplified by observational saturation, and that the gap between the federal catalogue and the public observational record is widening in ways that the public conversation about atmospheric events has not fully caught up to. The cluster is real, the events are real, the physics is well understood, and the most editorially interesting question the cluster raises is what it means that we are now able to see, in real time, atmospheric events that the federal detection chain is only catching a subset of. There is one more dimension to the statistical framing that I want to walk through before closing this part, because it is the dimension that the conspiracy-adjacent framings sometimes try to claim, and that is in fact the most defensible piece of departure from the strict null hypothesis. The dimension is that the historical CNEOS baseline rate against which we are comparing the cluster is, itself, an undercount of the actual atmospheric flux of small bodies into the Earth's atmosphere, and the size of the undercount is the relevant quantity for understanding what the cluster is telling us. Consider what the catalogue actually captures. It captures bolide events at and above approximately 73 gigajoules of total impact energy, and it captures them only when at least one of the contributing sensor networks happens to be in the right configuration to detect the event. The contributing networks include the classified satellite sensors I mentioned earlier, the infrasound stations of the CTBTO International Monitoring System, occasional seismic registration through the USGS network, and the GLM aboard the GOES series of satellites. Each of these networks has its own coverage geometry, its own detection threshold, and its own operational availability. Not every event that crosses the energy threshold is caught by at least one of them. Some events occur in geometries where no contributing sensor is looking. Some events occur at intensities that fall below the operational threshold of whichever sensor happens to be in the right position. Some events are caught by sensors whose data is not, for various operational reasons, flowed to the public catalogue in a timely fashion. The aggregate effect of all of these undercount mechanisms is that the catalogue rate is a lower bound on the actual rate of atmospheric bolide events at the relevant energy class. The true rate is higher. How much higher is a question that the academic literature on bolide flux has tried to answer over the past 2 decades, and the consensus is that the catalogue captures something like 50 to 80% of the events at the catalogue energy threshold, with substantial uncertainty on both ends of that range. If we apply that correction to the United States contiguous rate of 2 to 5 kiloton class events per year, the corrected estimate for the actual rate might be in the range of 3 to 8 kiloton class events per year over the lower 48 states. That correction does not change the qualitative conclusion that the 4-day cluster is at the tail of expected variation, but it does shift the tail probability somewhat. Under the corrected rate, the probability of a 4-day cluster of 2 kiloton class events is closer to 5 to 12% per year, which is still uncommon but somewhat less rare than the uncorrected estimate suggested. The point of working through the correction is not to give you a more precise probability. The point is to underline that the federal catalogue is the floor of what we can confirm, not the ceiling of what is actually happening. There is, structurally, a population of unattributed events sitting beneath the catalogue floor, and the size of that population is the relevant quantity for understanding what the public observational record is now able to see that the catalogue has historically missed. That is the central thesis I want you to take into the next part of the video, where I will walk through the 3 interpretive framings that the cluster supports and identify which one the editorial spine of this discussion leans on. Part 7. 3 ways to read the sky. When you have a cluster of atmospheric events that sits at the tail of expected variation, but inside it, there are, broadly speaking, 3 interpretive framings that the data supports. I want to walk through all 3 because each of them has a different implication for what the cluster is telling us, and because the editorial spine of this video has a clear preference among the 3 that I want to make explicit before we get to the conspiracy-adjacent framings in the next part. The first interpretation, and the one that is technically the null hypothesis under standard statistical reasoning, is that the cluster is a sporadic background fluctuation amplified by the maturation of the observational infrastructure. Under this interpretation, the underlying rate at which small to medium meteoroids enter the atmosphere over the contiguous United States has not changed in any meaningful sense. The events we are seeing in the cluster would have been happening at approximately this rate for as long as the Earth has been sitting in its current heliocentric orbit. What has changed is the density of consumer-grade optical sensors looking up at the sky. The cluster is at the high end of what random Poisson statistics allow. The geographic distribution is consistent with where the observers happen to be concentrated, and the federal catalogue will catch up to the public observational record over the next several weeks as AMS aggregation and CNEOS updates flow through their normal timelines. This is the boring interpretation. It does not require any new physics, any new astronomical phenomenon, any new federal disclosure asymmetry beyond the structural detection chain differences I've already described, and any departure from the underlying baseline rate of atmospheric impacts. It is the interpretation that most working bolide researchers would, in the absence of further evidence, default to. It is the null hypothesis in the formal sense, and the burden of proof for departing from it lies with whoever wants to claim a different interpretation. The second interpretation, and the one that the editorial spine of this video leans on, is that the cluster is a sporadic background fluctuation amplified by the maturation of the observational infrastructure, and, additionally, that the observational and acoustic envelope of the cluster is being amplified by the unusually persistent atmospheric pattern that has been dominating North American circulation since the middle of May. The omega block configuration produces upper tropospheric stratification of the kind that, in the Cape Cod case, may have widened the acoustic footprint of the bolide breakup to 3 states. The same configuration is still in place. The cluster events of June first occurred under atmospheric conditions that are not standard, and the observational saturation of the cluster events may be partially attributable to those non-standard conditions amplifying both the acoustic and visual envelopes of what would otherwise have been a more localized observation. This interpretation does not require any change to the underlying meteoroid flux either. It treats the underlying flux as the same baseline that the first interpretation does. It adds, as a contributing factor, the atmospheric pattern as an amplifier of how widely each individual event is observed. Under this interpretation, the cluster's public perception intensity is being driven by three factors: the underlying random Poisson variation at the tail of normal, the observational saturation of consumer-grade sensors, and the atmospheric pattern that lets each individual event be seen and heard farther than it would be seen and heard under standard conditions. The three factors together account for the cluster without requiring any departure from baseline. This is the interpretation the editorial spine of this video leans on, because it is consistent with the data we have. It is consistent with the broader pattern of weather behaviour we have been covering on this channel for the past 3 weeks, and it provides an explanatory framework that ties the cluster to the same parent atmospheric phenomenon that has been driving the heat dome, the floods, the nor'easter, and the drought break we have been documenting. The omega block is the connective tissue. The cluster fits inside it the same way the heat dome and the nor'easter fit inside it. The atmosphere itself is acting like an amplifier of every kind of event happening underneath it, and the cluster is one more expression of that amplification. The third interpretation, and the one I want to be careful about because it veers into territory that is genuinely speculative and that does not have the evidentiary support of the first two, is that the cluster is the result of an encounter with a fragmented parent body or a stream of debris on a heliocentric orbit that happens to be intersecting Earth's path during the first week of June 2026. Multi-event fireball clusters from a single fragmented parent body are documented in the scientific literature. The most famous example is the Pribram-Neuschwanstein pair, two meteorites that fell 16 years apart in 1959 and 2002 on nearly identical heliocentric orbits, leading to the conclusion that they had originated from the same parent asteroid that had broken up at some point in the distant past. Multi-event clusters spaced days apart on consecutive nights are rarer, but they would, in principle, be possible if a fragment cloud were on a heliocentric orbit close enough to Earth's that the encounter geometry produced atmospheric entries on consecutive nights at roughly the same latitude band. The geometric considerations are exacting. For the 4-day cluster, the fragment cloud would need to be on a heliocentric orbit that intersects Earth's orbit at the precise crossing point Earth happens to be passing through during the first week of June. The orbit would need to have a relative velocity that produces atmospheric entry speeds in the observed range, which for Cape Cod was 42,000 miles per hour, and for the Midwest event is unknown but inferred to be in a comparable range. The spatial extent of the cloud would need to be large enough that Earth's motion through it produces atmospheric entries at intervals of hours to days, and the cloud would need to be either spatially localized in a way that produces the observed latitude band concentration, or distributed broadly enough that the band concentration is purely an observer density artifact. None of those geometric considerations are impossible. None of them, by themselves, rule out the stream encounter hypothesis. But the cumulative weight of them, combined with the absence of any observational confirmation from Southern Hemisphere networks of an anomalous fireball rate during the same window, makes the stream encounter interpretation the weakest of the three under the data we currently have. If the cluster were the result of a stream encounter, we would expect to see, eventually, additional events in other regions and at other latitudes that did not fit the observer density amplified explanation. We have not seen those yet. We may yet. The hypothesis remains open. But it is not the interpretation the editorial spine of this video leans on. The first interpretation is the null hypothesis and the technically correct default. The second interpretation is the editorial lean, because it is consistent with the broader atmospheric context the channel has been covering. The third interpretation is the speculative tier, and it should be held lightly, with no claim of evidentiary support beyond the bare geometric possibility. One more thing about the stream encounter hypothesis, because it ties to a piece of context that some viewers will already be holding. The early June calendar window does contain 2 meteor showers that are operationally active during this period. The Arietids, which peak around June 7th, and the daytime Zeta Persids, which peak around June 9th, are both daytime meteor showers in the sense that their radiants are positioned such that the meteors enter the atmosphere from a direction that places them in the daytime sky from a ground-based observer's perspective. They are real, they are catalogued, and they do produce elevated meteor rates during their active periods. But they do not produce a significant nighttime contribution to the visual meteor rate from a ground-based observer's perspective, because their radiants are on the daylight side of the sky during peak observation hours. They are detected primarily by radar, not by visual observation. So the Monday night Midwest fireball and the Monday night Maine fireball cannot, on geometric grounds, be attributed to either of those showers. The radiants are wrong. The timing of the radiants on June 1st is several days before peak, when the rates would be even lower than at peak. The atmospheric entry directions reported by eyewitnesses, to the extent any directional information has been extracted, are not consistent with either shower's radiant. The stream encounter hypothesis, if it were correct, would require a different parent body and a different stream than either of the active early June showers. That does not refute the hypothesis, it just constrains it. If there is a stream encounter happening, it is not the Arietids and it is not the daytime Zeta Perseids. It would have to be a previously uncatalogued stream, which would itself be a notable discovery and would warrant academic publication. None of that has happened yet. The hypothesis remains open, it remains weak, and it remains, for purposes of this video's central thesis, the third tier among three possible framings of the cluster. Part 8. The Frames. This video will not adopt. Whenever the channel covers a cluster of unusual atmospheric events, the comment section produces a predictable set of alternative framings. I want to address each of them directly, in the order in which they typically appear, so that the audience watching this video understands what we have considered, what we have rejected, and why. The first alternative framing is that the federal government knows what these events are and is deliberately concealing the information from the public. This framing has a particular variant that has become more prevalent in the past several years under the broader rubric of unidentified aerial phenomena discussions, and it deserves a serious response rather than a dismissive one. The Stillman of this framing goes as follows. The federal disclosure on the Cape Cod event arrived within 48 hours of the entry. It included specific instrumental attribution to a named satellite instrument. It was followed by a detailed update with energy, trajectory, mass, and meteorite full location information. That is fast and detailed. The absence of comparable federal disclosure on the Midwest and Maine events, 5 days later, given the brightness and the multi-state visibility, can be read as evidence of selective disclosure, which would imply that the federal agencies involved have access to information about the latter events that they are choosing not to release. The counter-Steelman, the response that the technical evidence supports, is the following. GLM is daylight and nighttime capable, but its detection threshold for nighttime atmospheric flashes against dark backgrounds is calibrated differently than its daylight bolide attribution. The Lake Erie bolide of March 2026, which is the operational precedent for GLM-based federal attribution, was a daytime event over a region with clear skies. The Cape Cod event was a daytime event under cloud cover. Both fell within the operational regime where GLM has demonstrated rapid attribution capability. The Monday night Midwest fireball and the Monday night Maine fireball occurred at night, which is the operational regime where GLM's contribution to attribution is structurally different and where the primary attribution pathway is the multi-day to multi-week American Meteor Society and Kineos catalog process. The asymmetry between Cape Cod's 48-hour resolution and the indefinite pending status of the Midwest and Maine events is therefore structural to the detection chain. It is not deliberate concealment. It is the operational reality that a daytime bolide above a cloud deck happens to be the case that the new federal capability handles well, and a nighttime bolide over the same continent is the case that the older attribution pipeline handles on its longer timeline. Both cases will eventually be in the public record. They will arrive at different times because they pass through different attribution pathways. That is the technical response. It does not require us to claim that the federal agencies are not doing anything we might be uncomfortable with on other questions. It only requires us to recognize that on this particular question, the asymmetry of disclosure is explained by the structural reality of how the detection chain works and does not require any additional explanatory framework. The second alternative framing is that the events are not meteors. The framing has several variants, and I want to walk through each of them. The first variant is that the events are classified military hypersonic flight tests. The Department of Defense has several active hypersonic weapons programs, including the X-60 test vehicle, the AGM-183 air-launched rapid response weapon known as ARRW, and the long-range hypersonic weapon known as Dark Eagle. All of these programs have produced visible atmospheric flight tests over the past several years, and the optical signature of a hypersonic vehicle in atmospheric flight can resemble a bright fireball under some viewing conditions. The counter is the following. Hypersonic vehicles in atmospheric flight produce a characteristic sustained continuous luminous trail, not a discrete fireball with terminal fragmentation. The Cape Cod event has a confirmed atmospheric breakup at 31 miles altitude with a recoverable meteorite fall into Cape Cod Bay. That is incompatible with a hypersonic vehicle, which would not fragment terminally and would not leave a meteoritic deposit. The Monday night Midwest fireball with its 8-second luminous trail is at the upper end of fireball duration but at the lower end of hypersonic vehicle visibility. The Maine green fireball, with its colour signature consistent with magnesium and iron emission lines from a stony meteoroid, is incompatible with the optical signature of a hypersonic vehicle, which would not produce the same spectral signature. The hypersonic flight test framing is ruled out by the available optical evidence. The second variant is that the events are satellite re-entries. The United States Space Command operates a public re-entry catalogue that tracks all uncontrolled re-entries of catalogued objects through Earth's atmosphere. The catalogue is publicly accessible through the SpaceTrack website and is updated in near real time. No satellite re-entries over the relevant North American latitudes are catalogued for the time windows of either the May 30th Cape Cod event or the June 1st Midwestern Maine events. The re-entry framing is ruled out by the available catalogue data. The third variant is that the events are some form of directed energy event or atmospheric weapon test. This framing typically appears in a particular set of social media communities and is associated with broader narratives about unconventional weapons capabilities. The technical response is that no detectable instrumental signal in any federal sensor layer is consistent with the directed energy framing for any of the events. The GLM signature for Cape Cod is consistent with a bolide and is not consistent with a directed energy event. The multi-camera visual records for the Midwest event are consistent with an atmospheric entry of a small meteoroid and are not consistent with a directed energy event. The Maine green fireball spectral signature is consistent with stony meteoroid ablation and is not consistent with any directed energy mechanism. The framing is not supported by the available evidence. The third alternative framing is that the events are related to weather modification, geoengineering, or some atmospheric intervention conducted by the federal government or by some other entity. This framing has become prevalent in the broader discourse about unusual atmospheric events and deserves a response. The energy budget rebuttal is conclusive. The HAARP facility in Alaska, which is the operational venue for any large-scale ionospheric heating experiment by the federal government, has a maximum radiated power of approximately 3.6 megawatts. The kinetic energy of the Cape Cod bolide, at 5.6 metric tons travelling at 42,000 miles per hour, is approximately 1 times 10 to the 17th joules. The HAARP facility, operating continuously at maximum capacity for the entire 1-year operational interval, would deliver an integrated energy of approximately 1 times 10 to the 14th joules. That is 3 orders of magnitude less than the kinetic energy of the Cape Cod bolide itself. There is no terrestrial energy source operating at the energy scale required to produce, deflect, or otherwise interact meaningfully with an incoming free-flying object of the Cape Cod object's kinetic energy. The weather modification framing is incompatible with the basic energetics of the situation. The cloud seeding rebuttal is also worth mentioning, because cloud seeding is sometimes invoked alongside HAARP in similar discussions. Cloud seeding is the dispersion of silver iodide or other ice-nucleating agents into existing cloud structures to encourage precipitation formation. The published scientific literature on cloud seeding indicates a local precipitation enhancement of 5 to 15% of the natural rate, in clouds that already contain sufficient moisture to produce precipitation. Cloud seeding cannot create clouds where none exist. It cannot move clouds. It cannot create or steer storm systems. It is not a relevant mechanism for any of the atmospheric events under discussion. The fourth alternative framing, and the one I want to spend the most care addressing, is that the cluster represents the beginning of a larger impact event. This framing typically takes the form of suggesting that the Earth is being targeted by a larger object, that the cluster is the precursor to a larger entry, and that the public is being kept in the dark about an approaching threat. The response here is to walk through the publicly available data on known asteroid close approaches in the relevant window, because that data is freely available, comprehensive, and tells a different story than the framing suggests. The Jet Propulsion Laboratory maintains a public close approach data tool that lists all known asteroids passing within a defined distance of Earth in upcoming periods. For the immediate window around this video's recording, the list contains 2 entries. Asteroid 2021 KN2 will pass at a closest approach distance of 8.9 lunar distances on June 3rd at 6:52 Universal Time, travelling at 8.91 km per second. Asteroid 2018 GE will pass at a closest approach distance of 16.3 lunar distances on June 7th at 14:05 Universal Time, travelling at 3.09 km per second. Neither of those asteroids is on an impact trajectory. Both will pass at distances well outside the geostationary satellite belt. Neither has an estimated diameter in the range that would produce significant atmospheric or ground effects, even if it were on an impact trajectory. The asteroid close approach list for the immediate window contains no objects that pose any threat to Earth. The Cape Cod event was a 5-foot stony meteoroid. The Midwest event, if it was indeed in the same class, was probably comparable. These are routine atmospheric entries by small bodies that, on the scale of the asteroid catalogue, are too small to even be tracked individually before atmospheric entry. The CENIOS catalogue records dozens of events of this size class globally per year. They are not, in any sense, evidence of a larger impact event. They are the small end of the meteoroid distribution that the Earth's atmosphere encounters routinely. I want to address this framing directly, because it is the framing that, in my experience covering events like this, produces the most genuine anxiety in the audience. The cluster is real. The events are real. The physics is well understood. The events are at the small end of the meteoroid distribution. There is no observable trajectory for any larger body that would constitute a threat in the foreseeable future. The cluster is not the beginning of anything. It is, at most, a tale of expected variation fluctuation in the normal background flux that the planet experiences every year. That is the technical reality. I will not soft sell it. The framing of a larger approaching threat is not supported by the data. I have walked through the 4 most common alternative framings, and I have addressed each of them in the level of detail that I think they require. None of them are supported by the available evidence. The cluster is not concealment. The cluster is not a hypersonic test or a satellite re-entry or a directed NG event. The cluster is not weather modification. The cluster is not a precursor to a larger impact event. The cluster is, on the available evidence, a tale of expected variation fluctuation in the natural background flux of small meteoroids into Earth's atmosphere, possibly amplified in its observational footprint by the persistent atmospheric pattern over North America, and revealed to public attention by the maturation of consumer-grade observational infrastructure that has changed how atmospheric events are documented in real time. That is, by my read of the available evidence, the most defensible interpretation of what we're seeing. Part 9. What the gap actually means. In the next several days, the public record on the Monday night Midwest fireball and the Monday night Maine fireball will almost certainly expand. The American Meteor Society will assign event identifiers. Volunteer researchers will reconstruct trajectories from the eyewitness reports. If GLM did register a flash for either event, the cooperating researchers at the University of Wisconsin-Madison and at NASA Marshall will eventually publish energy and trajectory estimates. The CENIOS catalogue will, on its multi-week timeline, add entries if the events were energetic enough to meet the detection threshold. The federal record will, in stages, catch up to what we already know from the dashcams and the webcams and the eyewitness aggregations. That catch-up process will not be dramatic, and it will not be coordinated. It will arrive in pieces over the next several weeks, in the form of academic publications, AMS event identifiers, CENIOS catalogue updates, and the slow accretion of the public record into a more complete picture of what hit the atmosphere over America between May 30th and June 1st of 2026. By the time the catch-up is complete, the cluster will probably be classified as a tale of expected variation fluctuation in the normal background flux, possibly amplified by the persistent atmospheric pattern, with no requirement for any new physics or new astronomical phenomenon to explain it. That is the interpretation that the technical analysis supports. That is the interpretation the editorial spine of this video leans on. And that is the interpretation that, by the time the federal record is complete, will probably stand as the consensus reading of the cluster. But the cluster has revealed something even if its interpretation is mundane. It has revealed the size of the gap between what enters the atmosphere over America and what gets formally attributed in real time. It has revealed that the federal detection chain has, in the past decade, developed one new capability for daylight bolide attribution under specific conditions, while the older attribution pipeline for nighttime events continues to operate on the same multi-day to multi-week timeline it has used for decades. It has revealed that the public observational record, built out of consumer-grade dashcams and public webcams and social media aggregation, has matured to a level where it is providing a real-time view of atmospheric events that the federal record is not keeping pace with. And it has revealed that the gap between those two records is wider than most of the audience has been told. That gap is the editorial point of this video. The Cape Cod confirmation closed one mystery. The cluster that has followed it has opened a different one, and the new mystery is not what is hitting the atmosphere. The new mystery is what the gap means. If the gap is, as the technical analysis suggests, just a structural feature of how the detection chain works, then it is a gap that will close itself over time as the observational maturity of the public record makes the case for federal infrastructure investment in faster nighttime attribution. The CNEOS catalogue will eventually include automated near real-time pipelines that leverage GLM data more comprehensively. The AMS eyewitness aggregation workflow will eventually be augmented by computer vision tools that compress the multi-week timeline into hours, and the public conversation about atmospheric events will, eventually, have access to the kind of real-time federal record that the Cape Cod case demonstrated is possible under specific conditions. That is the optimistic reading, and it is consistent with how federal scientific infrastructure has historically evolved in response to changing observational capabilities. If the gap is, as the more skeptical reading might suggest, a sign that the federal record has fallen behind the public observational record in ways that institutional incentives are unlikely to close on their own, then we are in a different conversation, and that conversation has implications that go beyond meteoroid attribution. It would mean that the country has, without anybody planning it, developed a parallel observational system through consumer technology that operates on a faster timeline than the federal system can match. It would mean that the public's real-time view of what is happening in the sky above them is now richer than the federal view in some respects, and it would mean that the federal system's role in producing the canonical public record of atmospheric events is becoming structurally less important than it used to be, even as the events themselves have not changed. I do not know which of those two readings will look correct in 5 years. I do not think it is possible to know yet. What I do know is that the 4-day window we have just lived through between Saturday afternoon at Cape Cod and Monday night at Sebec Lake and across 8 states of Midwestern sky has made the gap visible in a way that any prior window of comparable length probably could not have made it visible. The cluster did not change the underlying meteoroid environment. It changed our ability to see the gap between what is happening and what gets catalogued. The Cape Cod object is at the bottom of Cape Cod Bay. Whatever fragments the Midwest fireball produced are scattered across some piece of the eastern Great Lakes Basin, probably never to be recovered. Whatever fragments the Maine fireball produced are sitting somewhere in the forests of central Maine, probably never to be located either. The physical record of the cluster is, for practical purposes, lost to retrieval. The observational record is what we have, and the observational record is, on the basis of public sources, 4 days of bright atmospheric events across the eastern half of North America, of which one has been federally confirmed and the others are pending in the slower pipeline. The next time a 4-day window like this one arrives, and there will be a next time, the federal record will, on the trajectory the infrastructure is currently following, be slightly faster than it was this time. The public observational record will, on the trajectory of consumer technology proliferation, be even denser than it was this time. The gap will probably continue to widen for a few more years before the federal infrastructure investment catches up. And eventually, perhaps within the next decade, the public conversation about atmospheric events will look back at the early summer of 2026 as the moment when the gap first became impossible to ignore. That is what I think this cluster is actually about. Not what hit the atmosphere, not why, but how we are seeing it, and how the federal record is failing to keep pace with how we are seeing it, and what it means that for the first time in the modern history of atmospheric observation, the public observational record is, in some specific narrow respects, more complete than the federal one. The case on Cape Cod is closed. The case on the cluster is closed at the level of physics and open at the level of attribution timing. The case on what the gap means between the federal record and the public one will stay open for a long time, and will probably be one of the central questions that atmospheric observation has to answer over the next decade. The sky above America has not changed. Our ability to see it has changed dramatically, and the federal record of what we are seeing has not yet caught up. That is, by my read of the evidence and by the editorial discipline this channel tries to bring to events like this one, what 5 fireballs in 4 days actually means. Not an omen, not a warning, not the precursor to anything. Just a window, briefly opened, into the size of a gap that has been there all along, and that is finally beginning to become visible to the people standing underneath it.